Imagine standing beneath a starlit sky, the air crisp and still as a celestial parade unfolds above. Not one, not two, but 7 comets, cosmic wanderers from the depths of space, converge in a rare, breathtaking display. In late 2025, the inner solar system becomes a stage for an unprecedented astronomical event, a swarm of comets unlike anything seen since the dawn of modern telescopes. Among them, an interstellar giant, 3I/Atlas, barrels through, its origins tracing back to a distant star system. These icy travelers, each with its own story, race past Earth and the Sun in a tight 6-month window, their glowing tails painting the heavens. Some whisper of solar storms sparked by their passage. Others promise a naked-eye spectacle visible to anyone who looks up. Why are so many comets arriving at once? What wonders or dangers might this cosmic traffic jam bring? Buckle up, because 2025 is rewriting the rulebook of the skies, and you won't want to miss a single moment. This isn't just a story of comets, it's a tale of the solar system coming alive. As we dive into this extraordinary event, picture yourself as part of it, whether you're gazing through binoculars, tracking real-time data from space observatories, or simply marveling at the night sky. This narrative will guide you through the science, the spectacle, and the stakes, with vivid details to keep you hooked. By the end, you'll know exactly when and where to look, and you'll be inspired to join a global community of sky watchers. Share your thoughts in the comments, hit that like button if you're as excited as we are, and subscribe for more cosmic adventures, because this is a once-in-a-lifetime show. Most years, the inner solar system plays host to a mere handful of comets. 1 or 2 bright enough to catch astronomers' attention, maybe 3 if the skies are generous. But 2025, it's a cosmic jackpot. 7 major comets, each a massive ball of ice and dust, are converging in a 6-month sprint, a phenomenon so rare it defies the records of modern astronomy. Since systematic sky surveys like Pan-STARRS, Linear, and Atlas began scanning the heavens, no year has seen this kind of traffic. The last time comet counts even flirted with these numbers, astronomers were peering through rudimentary telescopes, jotting notes on glass plates, and discoveries spread by word of mouth. This isn't a slow drip of visitors over years. It's a concentrated rush, a celestial stampede. What makes this swarm extraordinary isn't just the number, it's the timing and diversity. These comets aren't trickling in, they're charging through in rapid succession, some hailing from the solar system's frozen fringes, others looping back on periodic orbits, and one, 3I/Atlas, arriving from beyond our cosmic neighborhood. The odds of such a convergence are vanishingly small. Since 2000, the average year has seen just 1 comet bright enough to spot without a telescope, with a couple more visible through binoculars. Many years pass with nothing but faint, distant fuzzballs. Even in so-called comet showers, when a few objects arrive together, 7 is unheard of in the digital era. According to the Minor Planet Center's logs, no season since modern surveys began has hosted more than 4 major comets with perihelion, their closest approach to the sun, inside 2 astronomical units, about 186 million miles. Add in their tight alignment with the ecliptic, the plane of the planet's orbits, and you've got a statistical unicorn. This swarm is a multi-act drama, a cosmic choreography that astronomers are scrambling to map. Each comet follows its own path, yet together they form a singular event, a spectacle that challenges our understanding of the solar system's rhythm. The excitement isn't just scientific, it's universal. Whether you're an amateur stargazer or a seasoned researcher, this is a moment to pause and look up. In the comments below, tell us, have you ever seen a comet? What's got you most excited about this swarm? Let's dive into the cast of characters lighting up the 2025 sky. The 2025 comet season kicks off with C/2022 N2 Pan-STARRS, a distant opener that sets the stage. On July 31st, 2025, it reaches perihelion at 3.82 astronomical units, AU, well beyond Mars's orbit, where sunlight is faint and only the most sensitive telescopes can track its glow. This quiet prelude is like the soft hum before a symphony, hinting at the drama to come. Next up is C/2025 R2 Swan, a showstopper discovered on September 11th, 2025. Just one day later, on September 12th, it hits perihelion at a mere 0.50 AU, closer to the Sun than Venus. On October 21st, Swan sweeps past Earth at just 0.25 astronomical units, about 23 million miles, making it a prime target for observation in the pre-dawn sky of the northern hemisphere. Its tail stretches across the heavens, a shimmering arc visible through binoculars or even modest telescopes. Swan's close encounter offers a rare chance to witness a comet's dance with both Earth and Sun in real time, its tail twisting in the solar wind. 414P/STEREO, arriving on September 27th, takes a daring plunge to 0.52 AU, dipping below the ecliptic plane. This low trajectory makes it tricky for ground-based telescopes, often lost in the sun's glare, but it's a goldmine for spacecraft like Stereo, which capture its journey from angles we can't see from Earth. Its path is a reminder that not every comet plays by the same rules. C/2025 K1, Atlas, storms in on October 8th, diving to a scorching 0.33 astronomical units, closer to the Sun than Mercury. This tight solar pass triggers rapid changes, with outbursts of gas and dust sculpting a dynamic tail. Astronomers are glued to their screens, watching for flares that could reveal the comet's inner secrets. Then comes the interstellar headliner, 3I/Atlas, a visitor from another star system. On October 21st, it reaches superior conjunction, slipping behind the Sun from Earth's perspective before hitting perihelion on October 29th at 1.36 astronomical units, just inside Mars's orbit. With a near ecliptic trajectory, it shares the sky with planets and other comets. Its massive coma, a cloud of gas and dust spanning 700,000 kilometers, rivaling Jupiter's size. This alien wanderer is rewriting what we know about our cosmic backyard. C/2025 A6 Lemon steals the spotlight in November, peaking at perihelion on November 8th at 0.53 AU. Its evening glow, potentially reaching magnitude 4 or even 3.5, makes it a naked eye candidate for northern hemisphere viewers. Low in the southwest after sunset, Lemon's bright coma and tail offer one of the easiest viewing opportunities of the swarm. Finally, 240P/NE, a periodic comet, closes the season on December 19th at 2.12 astronomical units. Fainter and farther out, it's a subtle finale, underscoring the crowded chaos of the inner solar system by year's end. Each comet brings its own personality, some bold and bright, others elusive and fleeting. Together they form a cosmic ensemble, their paths weaving a tapestry across the sky. Which comet are you most excited to spot? Drop your pick in the comments and let's keep the conversation going. Comets are more than just pretty lights. They're cosmic messengers, their tails tracing the invisible forces of the solar system. As a comet nears the Sun, solar radiation heats its icy nucleus, releasing gas and dust that form two distinct tails: a broad pale dust tail sculpted by sunlight and gravity, and a narrow electric blue ion tail shaped by the solar wind, a stream of charged particles racing outward at hundreds of miles per second. The ion tail is where the real drama unfolds. Made of charged particles, it's a direct line to the Sun's magnetic field, twisting and bending as it rides the solar wind. But it's not indestructible. A sudden shift in the interplanetary magnetic field, say from a coronal mass ejection, CME, or a crossing of the heliospheric current sheet, can snap the tail clean off in a tail disconnection event. Picture it, the tail breaks away, drifting into space like a cosmic kite cut loose, while a new one begins to form, aligned with the solar wind's new direction. In April 2007, the Stereo spacecraft captured this exact phenomenon with Comet Encke, its ion tail severed by a CME in a sequence that matched simulations frame for frame, with 2025's Swarm arriving during solar maximum. When CMEs are expected at 2 to 5 per week, the odds of witnessing such a spectacle are sky high. The dust tail, by contrast, is steadier, shaped by sunlight's gentle push and gravity's pull. Only the most powerful CMIs can disrupt it, stripping away parts of the coma or redirecting its flow. For skywatchers, the ion tail's sudden breaks and regrowth are the signatures to watch, a vivid display of the Sun's restless energy written across millions of miles. Want to catch one of these events? Keep an eye on solar observatory feeds like SOHO's LASCOC3, available online for anyone to monitor. Share your sightings in the comments. Let's see who spots the first disconnection. This comet swarm isn't just a visual feast, it's a scientific battleground. Solar physicists are buzzing with anticipation, but also unease, as they debate what these close passes mean for the sun's behavior. Some, like NASA's CCMC modeling team, argue that the influx of cometary plasma and dust, especially from ecliptic-aligned comets, could nudge the sun toward more frequent or intense outbursts. Their simulations suggest that when a comet crosses the heliospheric current sheet or meets a CME, the magnetic field lines draping around it can shift rapidly, triggering tail disconnections or even seeding new instabilities in the solar wind. But not everyone's on board. Teams from Solar Orbiter and Parker Solar Probe point to in-situ data showing that most tail disruptions are subtler than models predict. Think minor kinks rather than dramatic breaks. They argue that the sun's own magnetic cycles, not comets, drive the show, with comets acting as passive tracers rather than active players. Even during the 2007 Enki event, operational impacts on satellites or power grids were negligible. Still, with CMEs peaking in late 2025, both sides agree this swarm is a rare chance to test their theories. Space weather officials are ramping up monitoring, and citizen scientists worldwide are gearing up for a global campaign. If a tail disconnection happens in view, everyone from backyard astronomers to spacecraft teams will be ready. This debate isn't just academic, it's a window into the sun's volatile nature. As you watch these comets, you're witnessing a cosmic experiment unfold. Have you ever seen a solar storm's effects, like auroras or tech glitches? Share your stories below and let's connect over the sun's wild side. Among the swarm, 3I/Atlas stands out like a stranger in a crowd. Unlike its companions, born in our solar system's icy outskirts, this comet hails from another star system, its hyperbolic orbit screaming one-way trip. With an eccentricity well above 1, it's not orbiting the sun, it's passing through, never to return. Only two other interstellar objects, Oumuamua 2017 and Borisov 2019, have been confirmed before it, but 3I/Atlas is a beast of its own. Its nucleus, estimated at 320 meters to 5.6 kilometers wide, is shrouded in a coma spanning 700,000 kilometers, nearly as wide as Jupiter. This massive halo, dominated by carbon dioxide with scant water vapor, hints at a composition forged in a distant cosmic crucible. Spectra revealed traces of cyanide and other volatiles rarely seen in such abundance in local comets. Its trajectory, skimming the ecliptic by just 5 degrees, and its blistering speed confirm its alien origins. As it rounds the sun, 3I/Atlas leaves a trail of dust and debris that Earth may cross in 2026, offering planetary defense teams a rare chance to study interstellar material up close. Every observation of 3I/Atlas is a glimpse into another star system's history. Its chemical fingerprints, unlike anything in our cosmic neighborhood, challenge what we know about planetary formation. As researchers track its path, they're piecing together a story that stretches across light years. What do you think this interstellar visitor might teach us? Drop your thoughts in the comments and let's speculate together. For millennia, comets have captivated humanity, sparking wonder, fear, and curiosity across cultures. In ancient times, they were omens, harbingers of change, God's messages, or warnings of doom. Today, we see them through the lens of science, yet their magic remains undimmed. The 2025 comet swarm is a bridge between those ancient gazes and our modern quest for knowledge, a reminder that we're all part of a vast, dynamic universe. Each comet in this swarm carries a story, not just of its own journey, but of the solar system's history and our place within it. As C-2025 R2 Swan streaks across the pre-dawn sky, its tail a shimmering ribbon against the stars, it invites us to pause and reflect. What does it mean to witness a traveler that's been hurtling through space for eons, only to blaze into view for a fleeting moment? For many, it's a humbling reminder of our smallness in the cosmic tapestry, yet also of our unique ability to observe, understand, and dream. Lemon's evening glow, bright enough to spot without a telescope, feels like a gift to backyard stargazers, a chance to connect with the universe from your own backyard. And 3I/Atlas, with its alien origins, whispers of worlds beyond our own, sparking questions about life, creation, and the boundaries of our cosmic home. This swarm isn't just a scientific event, it's a shared human experience, uniting people across continents as they look up in awe. Whether you're sketching Swan's tail, photographing Lemon's coma, or sharing Soho's coronagraph feeds online, you're part of a global story. Join the conversation in the comments. What emotions do these comets stir in you? Have they inspired you to learn more about the stars? Let's share the wonder and keep this cosmic connection alive. The 2025 Comet Swarm isn't just a gift to the eyes, it's a triumph of human ingenuity. Modern telescopes, spacecraft, and citizen science are converging to unlock secrets that would have been unimaginable a century ago. When Pan-STARRS first spotted C 2022N2, its faint glow was captured by a network of robotic telescopes scanning the skies nightly, a far cry from the days when comet discoveries relied on a lone astronomer's patience. The ATLAS survey, which caught C/2025K1 and 3I/Atlas, uses advanced algorithms to sift through terabytes of data, spotting fleeting objects that move too fast for human eyes to track. Spacecraft like Stereo and Soho play a starring role, their coronagraphs revealing comets like 414P/Stereo as they skirt the sun's edge, where ground-based scopes are blinded by glare. Meanwhile, Hubble and the James Webb Space Telescope are peeling back the layers of 3I/Atlas's massive coma, analyzing its carbon dioxide-heavy chemistry with precision that rewrites textbooks. But it's not just professional tools stealing the show. Citizen scientists are stepping up too. Apps and online platforms let anyone with a smartphone or laptop join the hunt, reporting outbursts or tail disconnections in real time. The Vera Rubin Observatory, set to launch its legacy survey of space and time, LSST, in 2025, promises to revolutionize this further, capturing faint comets and interstellar objects with unprecedented clarity. This technological symphony is turning the 2025 swarm into a treasure trove of data, from tail dynamics to interstellar chemistry. It's a testament to what humanity can achieve when curiosity meets innovation. Have you tried using an astronomy app or checked out SOHO's live feeds? Share your tech-driven stargazing tips in the comments, and let's inspire each other to dive deeper. As the 2025 Comet Swarm blazes through, it's not just a spectacle for today, it's a launch pad for tomorrow's breakthroughs. Each comet is a time capsule, carrying clues about the solar system's birth, and, in the case of 3I/Atlas, the mysteries of distant stars. The data pouring in from this event will fuel decades of research, from refining models of solar-wind interactions to preparing for future interstellar visitors. The debris trail left by 3I/Atlas, which Earth may cross in 2026, is a golden opportunity for planetary defense teams to study how alien material behaves in our orbit, a dry run for detecting and deflecting potential threats. Meanwhile, the swarm's timing during solar maximum offers a rare chance to probe the sun's magnetic moods, with each tail disconnection or outburst adding a piece to the puzzle of space weather forecasting. Looking ahead, the Vera Rubin Observatory's LSST will build on this moment, spotting comets and other transients with a sensitivity that could catch dozens more in a single year. But beyond the science, the 2025 swarm is a call to action for the next generation of explorers. It's inspiring students, amateurs, and dreamers to pick up telescopes, code new algorithms, or simply gaze upward with fresh curiosity. This event reminds us that the universe is full of surprises, and our tools, passion, and collaboration will keep unveiling them. What do you hope the 2025 swarm will teach us about the cosmos? Drop your ideas in the comments, hit that like button if this inspires you, and subscribe to stay in the loop for more cosmic discoveries. The future of stargazing starts now. Let's shape it together. The 2025 Comet Swarm is not just a collection of individual travelers, it's a grand celestial ballet, where each comet's orbit interweaves with the others, creating a dynamic interplay that captivates astronomers and skywatchers alike. Picture the solar system as a vast stage, with the sun at its center, its gravitational pull orchestrating the movements of these icy performers. Each comet follows a unique path, shaped by its origin, speed, and interaction with the sun's radiation and magnetic fields. C/2022 N2 Pan-STARRS sets the tempo with its distant, leisurely arc, while C/2025 K1 Atlas dives in close, its tight orbit accelerating its transformation under the sun's intense heat. The ecliptic alignment of this swarm adds a layer of complexity, as most comets skim the plane where the planets dance, creating a rare alignment that makes them visible alongside familiar celestial landmarks like Venus or Jupiter. This convergence amplifies the swarm's impact, turning the night sky into a crowded theater where multiple acts unfold simultaneously. The interplay of their tails, some stretching millions of miles, others snapping off in solar storms, reveals the invisible currents of the solar wind, like ripples on a cosmic pond. For scientists, this is a chance to study how comets interact not just with the sun, but potentially with each other's dust trails or plasma wakes, a phenomenon rarely observed at such scale. Imagine the possibility of 3I/Atlas's interstellar debris crossing Swan's path, creating a fleeting meteor shower or altering the dynamics of their ion tails. This swarm is a living laboratory where every orbit, every outburst tells a story of gravitational tugs, magnetic battles, and cosmic chemistry. For viewers, it's a visual feast, a chance to witness the solar system's machinery in action. Have you ever tried tracking a comet's path with a star chart? Share your experiences in the comments, and let's map this cosmic dance together. There's something deeply human about gazing at a comet, a fleeting visitor that lights up the sky for a moment before vanishing into the void. The 2025 swarm, with its 7 celestial travelers, taps into a primal connection to the universe, stirring emotions that range from awe to introspection. When you spot C/2025 A6 Lemon glowing low in the evening sky, its soft radiance cutting through the twilight, it's hard not to feel a pang of wonder. What stories does this comet carry from its millennia-long journey? For some, comets evoke a sense of timelessness, a reminder that the universe operates on scales far beyond our daily lives. For others, they spark curiosity, urging us to ask big questions. Are we alone? What lies beyond our solar system? 3I/Atlas, with its alien origins, amplifies this, inviting us to imagine distant worlds where other beings might gaze at their own skies, wondering about us. The swarm's fleeting nature adds a bittersweet edge. Unlike the steady glow of stars, these comets will soon be gone, their brief visit a reminder to seize the moment. Across history, comets have inspired art, poetry, and philosophy, from ancient cave paintings to modern-day astrophotography shared on social media. Today, the 2025 swarm is uniting people in a shared act of discovery, from families stepping outside to spot lemons glow to online communities buzzing with real-time observations of Swan's tail. This collective experience fosters a sense of unity, reminding us that we're all passengers on a tiny planet marveling at the same cosmic show. Whether you're a poet, a scientist, or just someone who loves a good sky, these comets invite you to feel something deeper. What emotions do comets spark for you? Share your reflections in the comments, and let's capture the soul of this celestial moment together. Beyond their beauty, the 2025 comet swarm carries a subtle but critical message about our planet's place in a busy cosmic neighborhood. Comets, with their unpredictable paths and potential to leave debris in Earth's orbit, are more than just spectacles. They're reminders of the need to stay vigilant. The interstellar 3I/Atlas, with its massive coma and trail of dust, is particularly intriguing for planetary defense experts. As Earth may cross its debris path in 2026, scientists are gearing up to study how interstellar material behaves in our orbit, offering insights into detecting and deflecting potential hazards. While none of these comets pose a direct threat, their close approaches highlight the importance of tracking near-Earth objects, a field that's grown leaps and bounds since the days of manual telescope searches. Today, surveys like Atlas and Pan-STARRS catch thousands of objects yearly, feeding data to organizations like NASA's Planetary Defense Coordination Office, which monitors for risks. The 2025 swarm is a real-world testbed, allowing researchers to refine models of how cometary debris interacts with Earth's atmosphere, knowledge that could one day save cities from an asteroid or comet impact. Citizen scientists play a role here too, reporting unexpected outbursts or fragments that could signal new debris trails. The swarm also underscores the global effort to protect our planet, with missions like NASA's DART, successfully tested in 2022, proving we can nudge objects off course. As you watch these comets, you're not just seeing beauty, you're witnessing a chapter in humanity's quest to safeguard Earth. Have you ever thought about what it takes to protect our planet from cosmic threats? comets? Drop your thoughts in the comments, hit that like button if this sparks your curiosity, and subscribe to stay updated on how we're guarding the skies. The 2025 comet swarm isn't just for scientists, it's for everyone. From late October to early November, the sky opens a window for anyone with a clear view and a bit of curiosity. No fancy gear required, though binoculars or a small telescope will enhance the experience. Here's your guide to catching the highlights. October 21st, 2025. C/2025 R2, Swan, rise before dawn and look southeast. Swan makes its closest Earth approach at 0.25 astronomical units. Its tail stretching 2.5 degrees, 5 times the moon's width. At magnitude 6 to 7, it's faint but visible through binoculars, climbing 40 degrees above the horizon at civil twilight in the northern hemisphere. Perfect for early risers. October 21st to 29th, 3I/Atlas, as Swan shines. 3I/Atlas slips behind the sun at Superior Conjunction, out of sight for ground-based telescopes. But you can follow it online via SOHO's LASCOC3 coronagraph, which streams real-time images of comets near the sun. Watch for outbursts or tail disconnections. Citizen scientists, this is your moment to contribute. November 6th to 12th, C/2025 A6, Lemon. The easiest comet to spot. Lemon glows at magnitude 4 or brighter in the evening sky. Look southwest after sunset, low on the horizon. From dark sites, it may be visible to the naked eye, especially in the northern hemisphere. Its bright coma and tail make it a must-see. For comets near the sun, like 414P/stereo and C/2025 K1A/TLAS, check SOHO's public feeds online. These spacecraft capture what ground telescopes miss, and you can join the hunt for sudden changes. The best nights are October 21st for Swan and November 6th to 12th for Lemon. Mark your calendars, grab your binoculars, and step outside to witness the solar system in motion. Share your viewing plans in the comments. Where are you watching from? Predicting a comet's behavior is like chasing a cosmic wildcard. Models can estimate brightness, but they often miss by 2 magnitudes or more. A comet pegged to shine at magnitude 3 might fizzle to 5 or 6, while an overlooked dim speck can erupt into a dazzling display. Why? It's all about the unknowns, the grain size of dust, the mix of ices, the thickness of the crust. A slight shift in solar heating or a hidden fracture can rewrite the script overnight. For 3I/Atlas, the uncertainties are even wilder. Its nucleus size is a guessing game, with estimates ranging from 320 meters to 5.6 kilometers. Its carbon dioxide heavy coma defies typical comet chemistry, and the lack of water vapor keeps scientists scrambling to refine their theories. Even with Hubble and JWST data pouring in, each observation reshapes the forecast. The lesson: expect the unexpected. The upcoming Vera Rubin Observatory's LSST, set to launch in 2025, will catch more of these wildcards with its all-sky scans, but even then, comets will keep us guessing. As you watch, stay open to surprises, share your predictions in the comments, and let's see who gets closest. The 2025 comet swarm is more than a fleeting spectacle. It's a chapter in the solar system's ongoing story. From the interstellar enigma of 3I/Atlas to the naked eye brilliance of Lemon, these comets are testing our understanding of cosmic chemistry, solar dynamics, and planetary defense. As they blaze through, they leave behind data that will fuel research for decades, from tail disconnections that reveal the sun's magnetic moods to debris trails that could teach us about distant stars. But this isn't just for scientists. It's for you, whether you're a first-time stargazer or a seasoned observer. The 2025 swarm is a reminder that the universe is alive, unpredictable, and within your reach. Step outside, look up, and join a global community witnessing history. Share your photos, sketches, or stories in the comments below. Let's build a collective memory of this cosmic event. If this tale of comets has sparked your curiosity, hit that like button and subscribe for more journeys into the cosmos. The sky is calling. Will you answer?